So welcome once again to another fascinating math video. In this video, we shall be considering solving problem from logarithm, and it's a proof problem. It is seldom, if you look at the world of mathematics, in general, it's seldom to look at problem involving proof because it involves a lot of reasoning process and invention. But this problem on the board, I shall show you a very non-common way of solving it, all right? So before I go over to the solution of this problem, I'd like to inform you that I offer a private online math tutoring service, and I also do services for schools. If you're interested in these services, be very free to get across to me for the primary level, secondary level, even to the college level. So be free to get to me if you want any of these services, all right? So let's go back to the solution of this problem. Now over here, we are required to prove that the left-hand side is equal to the right-hand side. Yes, if U, V, S, T are all positive. This is intentionally given because the logarithm of a negative number is not defined in the set of real numbers. But when it comes to the set of complex number, the logarithm of a negative number is defined. They shall not be considered a complex case because that is beyond the scope of this work, all right? Now, so we are supposing that U, V, S, T are all positive so that the logarithm will define in the set of real numbers. Show that, in other words, prove that or verify that log to an arbitrary base, the base is not given, so it should be taken arbitrarily. But commonly, we normally take it as base 10, but it's arbitrary, all right? It's not necessarily base 10, but arbitrary. Log to an arbitrary base of U over V multiplied by log to an arbitrary base of S over T is equals to log to an arbitrary base of U over S multiplied by this entire expression, all right? So we have to prove that the left-hand side is equal to the right-hand side. Now, how do we go over to proving of this problem? There are various ways to carry out the proof. One way is to show that the left-hand side is equal to the right-hand side, which we shall adopt in this problem. Another way is to show that the difference between the left-hand side and the right-hand side is 0. So if we can show that the difference between the left-hand side and the right-hand side is 0, that's one way of showing that the left-hand side is indeed equal to the right-hand side, all right? Then the last way is to show that the quotient of this left-hand side and the right-hand side is 1. So if this can be established, any of these will be able to show that indeed the left-hand side is equal to the right-hand side. But once again, we'll adopt the method of going from the left to the right. So now in the left-hand side, we have the log to an arbitrary base of U over V multiplied by the log to the same arbitrary base of S over T. Now, this is the technique to apply. We're not working blindly. We know what we're doing, all right? Now, observe the right-hand side. You see we have U over S multiplied by V over T, all right? So we try to force in this expression through this, all right? Now, how do we do that? Now, if you observe this argument here, or rather this antilog, all right? We call it antilog. These are S over T is an antilog. It's a quotient antilog. While U over V is a quotient antilog. All right, if you observe this quotient antilog, what is missing, you see that the letter S is missing because on the right-hand side, we're having U over S. So if we can play a trick by forcing the S into it, it will be a very good idea, all right? So we can write this as equal to log to an arbitrary base of U over S multiplied by S over S. Why the choice of S? Because on the right-hand side, we are seeing U upon X. So we see we're not working blindly in this case. We know what we're doing, right? So please, if you get any value from this video, do me the favor to like, share, comment, all right? And also make sure you like the video, you share it, and you do your comments. So we have this at hand already, multiplied by log to base, an arbitrary base of S over T. So now we are going to rearrange this expression here. This become the log to the base arbitrary of U over S multiplied by S over V. You know, it's the same thing because this will cancel out with this. We'll be left with U over V. All right? Can you see that? And then multiply by this log to base S to base an arbitrary base of S over T. Sorry for the way of pronunciation. You know, it's not easy sometimes. So let's continue with the solution of this problem. Now, listen attentively. This time around, we are having U over S, which is what we desire here, all right? But the only trouble is this term, is this multiplicand. So how do we remove it? We shall apply a law of logarithm, which states that, let me use this part of the board to illustrate it. which says that log to base x of a product AB is equal to log to base s of A plus log to base x of B. All right, so whenever we have this expression, we can expand it as follows. So we apply this concept to this particular term. So let me remove this from the board. So we have it as equal to, on expanding this by the law I just quoted, we have it as log to base arbitrary of U over S plus log to an arbitrary base of S over V, right? We have this at hand. Then all multiplied by this latter expression, log to an arbitrary base of S over T. Can you see that? All right, so what we do now, we shall expand individually. Let this, we can distribute from the right, all right? We can distribute with this from the right because multiplication is right distributive over addition when it comes to the set of real number, because the set of real number is an example of a field, and every field has that property of distributivity, unless the system is not a field, and that concept of field is advanced. So I cannot talk of field here, unless we do that in a private class, right? So we distribute from the right. In this case, we have it as log to an arbitrary base of U over S multiplied by log to an arbitrary base of S over T, all right? Then plus log to an arbitrary base of S over V multiplied by log to an arbitrary base of S over T. Can you see that? Now, once again, comparing this with this, the only variation is that we are having V over T, but already we have the term U over S. It's already showing there. So we can play more trick again, the same way, all right? Now, this is how we're going to go about it. We shall write this as log to an arbitrary base of U over S multiplied by log to an arbitrary base of S over T, then times V over V. Why am I doing this? Because over here, I have a V over T. Can you see that? So we are good to go. Then with this plus log to an arbitrary base of S over V multiplied by log to an arbitrary base of S over T. All right? Now, this can be written as log to an arbitrary base of U over S multiplied. Now, rearranging this structure, you see here, that is this product, we have it as log to an arbitrary base of V over T multiplied by S over V. You agree with this expression? Look at it and convince yourself that it is so. Can you see that? Now we're almost there, all right? Now this is a product, all right? The product of V over T and the S over V. So we can use the law for expanding products of logarithm. Let me quote the law once again. If you have log to base x of AB, and this is equals to writing log to base x of A plus log to base x of B. Can you see that? So if we apply this again, I think this will be promising, all right? So let me remove this from here. So we have this as log to an arbitrary base of U over S multiplied by, now we apply this law again, we have our result as log to base an arbitrary base of V over T plus log to an arbitrary base of S over V. Can you see that? All right, so the work is coming out gradually. Log to an arbitrary base of S over V, log to an arbitrary base of S over T. That is, you write everything again. So now we can expand again. When we expand again, we have it as log to an arbitrary base of U over S multiplied by log to an arbitrary base of V over T, which is our desire. Now, look here. Okay, let me finish the expansion first. I will not confuse you. This multiplied by this, we have log to an arbitrary base of U over S multiplied by log to an arbitrary base of S over V. Then plus, write this expression. We have log to an arbitrary base of S over V multiplied by log to an arbitrary base of S over T. Can you see that? Now, if you observe this term, you see that is exactly what we are seeing here. Can you see that? So we succeeded in getting one of the 10. So the rest is to force this expression here to look like this. So I can call this I can write this as log to an arbitrary base of U over S multiplied by log to an arbitrary base of V over T plus P. All right? What is my P? Here, P is the entire expression you are seeing here. All right? So it is not logical to work on P to see whether we can reduce P to look like this other 10 you are seeing here. All right? So that is the logic we're going to use. So let me write it. Now, you know you write P in mathematics. Like when you are carrying out mathematical proof, if you introduce a new letter, you have to define what the letter is. All right, so we can say where P is equal to log to an arbitrary base of U over S, or multiplied by log to an arbitrary base of S over V plus log to an arbitrary base of S over V, once again, multiplied by log to an arbitrary base of S over T. So you have to indicate what P is, and this is what P is, all right? So what we do now, we simplify this expression in order to get this you see here, all right? So let's go there. For that, I will remove this from the board. All right, so we are good to go. Now, my P here is equal to writing. Or how do we simplify this? Now, listen, look at this side. We shall take a common factor. Now, if you look at this, is the first term and this is the second term, all right? Looking at the first term and the second term, you see that log to an arbitrary base of S over V is common to both terms. So we can factor this, all right? So when we do that, that's P become log to an arbitrary base of S over V, and that should multiply. When this divides this first term, we are left with log to an arbitrary base of U over S, all right? Then when this expression divides the second term, we're left with plus log to an arbitrary base of S over T. Can you see that? All right? Now, this will break down to writing log to an arbitrary base of S over V multiplied by, now, if you observe carefully, we can use the reverse of the product law I just explained. Let me state the law again. If we have log to an arbitrary base of X of AB, and this is equal to writing log to an arbitrary base of S of A plus log to an arbitrary base of S of B. Now, since the left-hand side, from the left-hand side, we can transform into the right-hand side. Conversely, we can from the right-hand side go back to the right-hand side, all right? So the reverse of the law is also possible. So in this case, reversing this by the law, by the reverse, it will become log to an arbitrary base of U over S multiplied by S over T, all right? From whence this S will cancel out with this S. You agree with that? So in this case, we'll be having log to an arbitrary base of S over V, or please let's call this one star for reference purpose, all right? We shall refer to it again if we're done with this side. Then multiplied by log to an arbitrary base of U over T. Now let's observe. Now if you look carefully, you see that we have log to an arbitrary base of U over T, and that is also found here, all right? Can you see it? And we have log to an arbitrary base of S over V, and that is found here. That means we'll be able to prove that P can be the second term. So inputting this result into equation star, we have our result that, therefore, from star, all right? From star, we have that the log to an arbitrary base of U over V multiplied by log to an arbitrary base of S over T is indeed equal to, you come here and put this, right? Log to an arbitrary base of U over S multiplied by log to an arbitrary base of V over T plus my P expression will be simplified to be this, all right? Can you see that? Look at it here. In this case, I can write log to an arbitrary base of S over V multiplied by log to an arbitrary base of U over T. So folks, we've come to the end of this video. See, it sounds interesting, look very interesting. So when carrying out proof in mathematics, you don't work blindly. You know what you do, all right? It takes more time. That's when you practice, you become better. So do me the favor to like, share, and make your comments on the video. Thank you very much for today.